just introducing polynomials, and we're describing how to find what's going to happen at the end of each polynomial, meaning like as you get farther and farther away from 0 in both directions. All right, this is a polynomial function written in its like standard form. And it's hard to read except for this is always a coefficient, and you have a variable to an exponent. That's a constant. Now in standard form, whatever the biggest degree is goes here, and then you count down from there. So if this is a 5, you go 5, 1 less than 5 is 4, 3, 2, 1, and then you have a constant with no so 0, x to the 0 power. All right, now in order to be considered a polynomial, the exponents have to be all whole numbers, meaning no negatives or fractions, decimals, right? They have to be whole numbers. The set of whole numbers also does not include any negatives as well. Otherwise, they'd be integers. The coefficients are the numbers without variables. All right, so the coefficients in this case would be the a to the n, or a subscript n. Right, it's the numbers out in front, or it's just the constant. Those would be all the coefficients. Now, degree. In degrees based on the largest exponent. Attached to the variable. Exponents make things big, so if something has an exponent that's bigger than the next exponent, it's going to eventually completely dominate the graph, and it'll control the shape. So if it's a degree 0, so if it has 0 is the biggest exponent, that's called a constant. First degree polynomials are called linear. Second degree polynomials, quadratic. And then after 3, we tend to cubic. After 3, we technically just say fourth degree. They all have cool Latin prefixes too, like quartic. But after 3, we tend to just use 4th, 5th, 6th, 7th, 8th degree polynomial. Okay, so in this section, supposed to pause the video and check to see which one of these is considered an actual polynomial. Which one's going to follow our rules? So our rules for it being a polynomial is that the exponents can't be negative, they can't be fractions. The coefficients have to be real numbers, no variables, right? I think it was supposed to say no imaginary numbers there. All right, so if we're looking at this, this is not a polynomial because it has an exponent that's a 1/2. That's going to cause other issues. So not a polynomial. This one is a polynomial. 5 is the biggest exponent. So we list it as, they want us to write it in standard form, so you have to write it in descending order. So the 5 is the biggest exponent. The next biggest exponent is 4. The next biggest exponent is 2. And then the next 6, this has an exponent of 0 because there is no x. It's the constant. The constant always goes at the end because it's the lowest possible exponent. That would be standard form. This would be considered a 5th degree polynomial with 1, 2, 3, 4 terms. Also a polynomial. And it's in standard form. This would be considered cubic. It's got a fraction, but it's the coefficient. It's not the exponent. This one has an exponent that's negative. That means it's a rational function. It is not a polynomial. Negative exponents cause it to follow a different set of rules. Fractional exponents cause it to follow a set of different rules. All right, direct substitution. Direct substitution is when you just plug in the number. So if they want to know when x is equal to 2, what we do is we put it in the little input window, right? X x is the variable. This is saying the function f kind of takes the place of y. Y follows x. All right, so y, the f, is going to be when x is equal to 2. So we just take 2 and we plug it in. Everywhere we see an x, we plug it in. And you do a bunch of math. Now we follow PEMDAS. We got to do exponents first. 2 cubed is 8 times negative 3. 2 squared is 4. Minus 24 minus 5. Negative 24. Minus 24 and more is negative 48. Negative 44. Negative 49. That's direct substitution. You just plug it right in. Now, synthetic substitution uses synthetic division to find the answer. Now, we're actually going to learn synthetic division later, so this is kind of a preview. All right, if we want to find this value, we can either plug it in like so, or we can use synthetic division with this. So we're going to take this 2, we're going to put it up here, and then we're going to set up everything else based on the coefficients. Now, the tricky part about this is you need a column for every degree. So this is a third degree, so we're starting with 3. So we need a column for x cubes, we need a column for x squareds, we need a column for x to the first, and then we need a constant column. You don't need to write these in. These are assumed that you're just counting down in order, so that just for the first time I'm writing it in. So we have a column for x cubes. So I put my coefficient for my x cubes in here. We need a column for the x squareds. The coefficient of x squared is 1. Column for my x to the first, we got a negative 12. And column for my constants, negative 5. I just write those down. I don't need to put the x's next to them. You could if you wanted. It's a waste of time. All right, and then you're going to do these two things. You're going to add down. You're going to multiply around. Add down, multiply around, add down, multiply around. So start. This is the adding row. Add down. Negative 3 plus nothing is negative 3. Multiply around. Take the 2 times negative 3. Put that number up here. 2 times negative 3 is negative 6. After you multiply around, you add down. 1 plus negative 6 is negative 5. Add down, multiply around. 2 times negative 5 is negative 10. Plus negative 12 is negative 22. Add down, multiply around. 2 times negative 22 is negative 44. Add down, negative 5 minus 44 is negative 49. And the very last number is your value. Oh, notice we got the same thing. All right. You can pause it and try it. All right, same thing. Do your coefficients. 1, negative 5, 6, 1. Put your 4 up here. And then add down, multiply around. Thing you have to be careful about is if you're missing one, you need to put a 0 in the column because you need 1 for every column. So this has 3, 2, 1, 0. This one has 4, 3, 2, where's 1? There is no 1, so you're going to have to leave a space there or put a 0 in. You need a column for each spot. So we're starting with x cubed. We're going to count down. We need an x squared. We need an x to the first. We need an x to the 0. Add down. Multiply around. Add down. Multiply around. Add down. Multiply around. 9 is the answer. That means if you plug in a 4 into this equation, you get a 9. That means like you have a coordinate at 4, 9. If you don't believe me, plug it in and see. Same thing here. Pause it, try it. Coefficient 1, 2, 3. We're missing the x to the first, so we have to add in that 0. Add down, multiply around. Negative 2 times 1 is negative 2. Plus 2 is 0. Times negative 2 is 0. 3, negative 6, positive 12, 5. Notice it's a lot faster. That means when f is of negative 2, when x is equal to negative 2, you get 5 as the total value here. Like if you were to graph this thing, you know, at negative 2, you'd have a dot at 5. End behavior. End behavior describes what happens at the far edges of the graph. So like as x approaches positive infinity, now the arrow means approaches. And positive infinity, as x approaches positive infinity, just like positive infinity is off to the right. This just means as x goes to the right. Whereas this x approaching negative infinity means to the left. You could also say it approaches a larger negative number and a larger positive number with words. But mathematically, this is how you state it. Okay, so they're asking, and notice in all 4 examples, x is always approaching positive infinity and negative infinity. That means we're going to look to the right and to the left. We look both ways before we cross the street. We're always going to look to the right, and we're always going to look to the left. The thing that's going to change is, does it go up or does it go down? Does it go up or does it go down? That's the decision we're making. It always goes left and right. We need to decide, does it also go up or down? And it follows one of 2 categories. The degree is either odd or it is even. If it's odd, it goes in opposite directions. So if the leading coefficient is positive, it's going to go up, right? Like a slope. We don't know what it's going to do in the middle because all the stuff that's involved in the equations going to happen, right? There's going to be some squiggles. But we know that it eventually is going to go up to the right, down to the left. How do we say that? To the right, it goes up. So you'd say it goes up. To the left, it goes down. So you'd say it goes down. It goes in opposite directions. If it has, and the a coefficient's almost like the slope, right? So like in this one, the a coefficient is negative. The degree is even. This one, the a coefficient is positive. The degree is even. The a coefficient is positive. The degree is odd, right? That's the decisions you're making. So the degree in this case, also odd. But now our leading coefficient's negative. Well, that just means the slope is negative. So it's going to go in opposite directions, going down. So that means to the right, it goes down. To the left, it goes up. That's how you say it goes down to the right, goes up to the left. Again, you don't know what's going to happen in the middle. That's an unknown. If the degree is even, it goes in the same direction. So if it has a positive a coefficient, it's going to go up on both sides, to the right and to the left. So it's going to go up in both directions. Naturally, if it has an even degree and the a coefficient's negative, just like a parabola with a negative slope, they're both going to go down. How do you say they both go down? You say negative infinity in both directions. I would pause the video and take your best guess for number 6. All right, so this, again, be careful. They should have listed it in standard form, but you don't know. What's the biggest exponent? 4. Okay, so that's even. And the leading coefficient is negative. Even means they go in the same direction. Negative means they go down. So you'd say as x approaches and as x approaches. Again, this is always the same. Positive infinity, negative infinity. Doesn't matter what order. You have to put the y next to the positive infinity so we know which one goes with which. So this one's to the right. It's going down. Why is it going down? It has a negative slope. To the left, it's also going down. Why? Because it's an even degree, and they both go in the same direction. All right, pause it and try the next one. This one, again, pay attention. They might have put it in the different form. Okay, 3 is the biggest. That's an odd degree. And the A coefficient is just +1. So that means it's going up. It's going to go down to the left, up to the right. How do we say that? We say it to the left and to the right by going positive infinity. Well, that's to the right. Negative infinity, that's to the left. What's it doing? Okay, this is where we have to fill in the blank. Those are the things we need to make a decision on. This is always happening. Okay, this means to the right, so to the right it's going up. This means to the left, it's going down. That's how you write it. Pause it and try the next one. Even, positive. Doesn't matter that it's a 2 versus a 1. It just matters whether it's positive or negative. Okay, even positives are going to go up in both directions. So we're going to say positive infinity, negative infinity, y approaches. Okay, I got to fill in the y's. So it's even, it's going up in both directions, so I'm just going to say it goes up to the left, to the right, up to the left. Last one. This one has an odd degree, and it's negative, A coefficient. That means it's going to go down. Opposite directions because it's odd, down because the A is negative. So now we go x to the right, x to the left. What's y doing? Well, to the right, it's going down. To the left, it's going up. That's how you write M behavior. So this one's backwards. Now they have the M behavior. Notice this one starts low, ends high. Which one starts low and ends high? This one. So that means head is an odd degree, and it has a positive A coefficient. Why don't you pause it and try the other two? This one, they both go in the same direction. They both go down, so it's a negative A coefficient, and it's an even degree. This one goes up to the left, down to the right, so it's opposite directions, so it's odd. And then it's going down overall, so we'd say it's a negative A coefficient.